Hi guys, so I'm here after hours working on a print job, and I was told they were having production staff was having problems with this machine. So I'm going to be working on this today. I'm going to take you through the process of how I'm going to resolve this issue. So first, let's just run the machine, and I can show you a little bit more. Now these are one of our finisher machines. This is an Aerocut G2. It's a fairly old machine, but it works really well. Japanese designed. We have it modified to work with long sheets. And there's a couple other modifications that I do want to share with you today. But let's start it up and see how it runs. So I have this tennis ball here to, if you're wondering, to basically even out the cross-sectional air fan that's blowing in the middle of the sheets. That kind of helps it even it out. It creates a pocket of air. But the problem mainly that we're having is this here, where there is a blade that cuts, but sometimes you have this little piece that gets stuck here, and it will eventually cause a jam. Now, if you're hearing that air noise, it's actually this nozzle. This is not part of the machines, and see how I just duct tape it together. What I did, let me just turn this off for a second. What I did a couple months ago was actually modify this machine to have this air system. Now in the closet behind this machine, I have an air system here. This is one of our main air systems that run a couple of the machines. It runs this machine, it runs a laminator, it runs both of those. We also have an air station there and a couple other systems in the building that this kind of goes all the way to the back. But since it's close by here, I decided, hey, you know what? Every time this cuts, I want to blow these pieces out from here. So let me just show you first the problem that I had without the air system. And I'm going to show you how the air system works. So I'm closing this nozzle here, valve, excuse me. I closed it, and it's going to just prevent the air from blowing every time it cuts. So let's just start it up again. And I'm going to show you how it works without the air system. So you can hear maybe that, I don't know if you can hear it, but the air system is off. You don't really hear that. You know, you see how those pieces, the end cuts, kind of stick to the blade. And sometimes it will just get stuck. When it gets stuck, it can actually get stuck inside the blade or before the blade and cause issues, jamming and double feeding, and it can cause a whole hot mess. Yeah, see how it gets stuck, especially right that one. So let's turn on the air. Alright, see how that blew out that sheet? So it blows it out here because that's where I put it. And the way it works is every time the blade cuts, it actually presses down on this micro switch that I installed here and I mounted. Now this micro switch, let me go to the bottom of the machine. So under here, a little bit of a mess. This bottom switch, that switch actually on the blade, is connected to this monostable circuit. This monostable circuit is basically a relay that will control this solenoid here, electronically control this solenoid. And why we need a monostatic relay is because every time it is pressed down, it's pressed down such a momentary short period of time that the air blown would just be also short. So this basically, once it receives a signal from the switch, this micro switch here, from the blade, it will hold down a little bit longer, or open up the solenoid a little bit longer, and it would spit out more air for a more period of time, which can be adjusted. So I adjusted it to the timing that I like. You can make it go longer burst of air or shorter burst of air. But yeah, that is why that is necessary. In the newer machines, they actually have a ion fan, which is an anti-static fan. But I feel that the anti-static is just only part of it. Actually, there was a cover here that had an anti-static brush, which didn't work that well. That's why I removed it in favor for this air system, which works wonderfully. But right now, I am having an issue where, like I was showing you, that this side is actually getting stuck because I only have air on here. There you go. Let me stop. So that is the problem. So basically, this air probably blew out this piece, but this piece, there's nothing there. So what I'm going to do is I'm going to open this up. I'm going to add a splitter. I'm going to actually add another tube and hopefully clear that out in the same manner of how that is working. So let's do that. Now I'm using this wire, I'm going to attach to the outside of the tube so that I could bend it and keep it in place, just like this. The tube is just a flexible tube, and it doesn't really have any way for it to stay in position, so hence the wire. I also like to use this duct tape when I'm doing such projects. This is a Gorilla tape. One of the strongest tapes that I've seen. The Gorilla brand is, they say it's incredibly strong. I don't know if you see this, but it is strong. You could feel it. Very thick, but also the adhesive is very tacky. Very sticky. Perfect for situations like industrial, where you really don't want things to fall apart, especially this, where you have a lot of moving parts, and something falls in here just slightly. For example, the blade can get significantly damaged. Actually, you know what? Instead of the tape, I'm going to actually do a heat shrink tube like I did this one. So basically, this is actually a tubing, heat shrink tube that I applied around the wire and the pneumatic tubing, air tubing itself. Let me just grab it. So what I use for that scenario, I'm going to go all the way to one of our electronics stations. So this is basically electronics lab station, and it's kind of odd to see this in the print shop, but don't forget we're also a tech company as well. One of my favorite tools is this. Now, this is a rework station, and it's used in SMD soldering, or mainly for us, we actually use it for other things as well, like a very tight glue gun. But I am going to use it in the case where I need to apply heat to a shrink tube. So let me just grab that. I also need the tubing itself. Again, these are more common to electronics. If you guys are into electronics, you know what I mean. Than it is to print. I think I use this. Not sure what the width is, but let me just grab a couple of these. All right. Let's head back to the finisher. All right, Alright, so I'm just gonna plug this in. Alright. Let's try to position this in a stable place. Good. And now for the tubing. The heat shrink tubing. So basically when heat is applied, this tube will actually shrink. This is a 2:1, so it should shrink to half the size. Okay, so I'm just going to encase. Let me now remove this duct tape first. Then I will encase the tube and the wire with the heat shrink tube. Alright, so I'm just gonna move it down all the way, and I will cut off this excess. I don't think I need it, otherwise I will use another tube, but let's just start with this first. So when I take it off, it will automatically turn on. There's a magnet sensor in here, knowing that I took off the head attachment, and now I will just run this over. So see how it's shrinking? See that? So we're just going to do kind of one side first, and then I'm going to kind of turn it around a little bit, rotate it a little bit, and do the other side. Alright, so let's try to get the other side. Now this glue gun, not glue gun, sorry, this heat gun is very hot. Again, this is a reworking station. If you see here, if you're wondering what this is, it's not a brand name one, but it works really well. It's an SMD workstation, and this is commonly used in the electronics industry, which I'm a part of. And it's very good though at heat shrinking tubing, because it will heat a small area. I could use a big heat gun with a wide head like this compared to this, but it kind of gets messy and it will heat the components around it, which sometimes you do not want to do. Alright, so let me just safely put this aside. Let's take a look at what else needs to be done. So now I can manipulate this. You know what? I'm going to tape this in a bit now, since it's already, I'm already done with that part. So I can just tape it back. Alright. I can tape it more later, but especially when I first install something or do mods, you don't want to completely finish it. You don't want to tape it completely because you're still figuring it out. Does it work? What's the best position? So I am kind of go follow the same way as I did with this one. You know what? Maybe I should tape this part down too, because it seems a little bit quite unstable at that point. At least to bend it. No, need longer tape. Oh. So I'm just gonna shrink this part now. And I probably will need to cut this to length, which is fine. You can just use a regular wire cutter to do that. Alright, let's get the other side. See how that's shrinking nicely. Keeps everything together. Alright. Let's just put this aside, let this cool off. This comes off. This is the creaser unit. So I kind of have to be careful that it's not in the way, because this needs to come off. If there's paper that gets jammed, the operator will need to open it up. And let's try to prevent them from hitting this thing by positioning it so that they can take this off without any problem. Okay, let's cut it a little bit. Where are my wire cutters? About an inch. I'll just tape it in. And then I'm going to start up the machine again, do some test cuts, and to see where we are with this. How does that sound, guys? Alright, for now. I know, it can move. Let's turn it on. Alright, just make sure everything is cleared. Yes. So we had this machine for maybe 10 years, maybe more actually. And it works still almost like the day we got it. We did replace the blade one time, but these sliotar wheels still lasting. These ones here, sorry, these and those. And those are just basically knives on a wheel, so they're just round knives, right? They seem to be working. Creaser units probably will last forever. But yeah, I mean, this machine is very well engineered. Japanese made. They're still selling versions of this. Aerocut, and it seems to work. I think the new one seems to work. It's very similar to this. I think they did upgrade the software wise, so that's good. But for us, it seems to suit our needs for now. Plus, don't forget we have the CNC machines as well over there, which we use quite more now that we have them than compared to this one. But this one is good in very, very large runs. They go a lot faster. So if it can be simple enough to set up on this machine, why not? Alright, so it's setting everything in position, moving these creasing wheels, sliotar wheels according to the cutting plan that we placed. Alright, oh, whoops, let me get this out of the way. I guess I should turn this off since we're working in a paper environment. Start. Oh, wait, no, that's cut. So again, this is the cutter button, and it will just activate that blade. Every time that blade presses down on this micro switch sensor here, it will activate the air. Oh, I did turn it off to show you guys, so let me open it up. So I just had to go off camera, opening up another valve. I turned off. Let me show you what I was doing. I have another valve here just to cut the air supply, just in case. So I turned that off as well, but I just opened it up. That's why it wasn't working. Alright, there you go. So every time I hit cutter, see how, look at that. Look at the how it moves every time I click cutter. So it seems to be working. Alright. Enough talk, let's run. If you happen to have this machine as well, similar, you're wondering, how come I can open the cover and have it run? By default, you can't. Oh, it seems to be working. I actually put another bypass of the safety switch here. So this is, if you have this machine, you probably don't have this because, well, I know you don't have this because I put this in, and that just basically tricks the sensor that it's open and closed. Now, when I do it, I turn it, I disable it when I need to, but I always put it back because I'm scared the production staff might, well, something might happen in production. But looks like it's working. Let's give it a few more sheets. Let's see how they go through. Oh, seems to be misfeeding here. You know what? Let me show you a trick that I do. So, since I have air, we commonly use air for many things. We have an anti-static gun. Actually, let me show you that. So we have a card here, and there's actually an anti-static which generates positive and negative ions and then shoots air. That's not always needed. It's only in a static scenario, mostly when we do polyester or vinyl labels. But sometimes we just need air to kind of jog the paper. Normally in a print shop this can be done by hand or jogging paper, but we like to do this. Watch. See how that's separating the sheets? Yeah, that worked. It works really well. Noisy. If you can hear the sound, you might not be able to hear it because my mic is close to the mouth, but it is quite noisy. But it does work. So, ready? All right. Again, this is the cutting blade right here. And that's the new air system. So just pay attention to the pieces. It just gets blown down immediately right away. Oh, if you're wondering where does it go? Down here, there's actually a chute to the side of the machine, bottom. There's actually a chute. Well, all these go. I actually shouldn't have moved this, but all these fall into a bin. You're supposed to clear out the bin every so often, but that's the idea. Everything that gets just sucked through or just drops through goes into a chute all the way down here. It seems to be working. I'm very happy, actually. First try. Very good. It's working really well. Alright, so I'm just going to end it here. I'm going to let the production team work on this. I'm pretty much done. Let me switch that bypass. So when that bypass is off, when the cover is open, it doesn't like it. It says it won't run for safety reasons. So that's why I had to put a bypass switch if you're wondering. But yeah, so far so good. I hope you enjoyed this video. Oh, before I go. Right here, I took off my headset mic so you can kind of hear it. But this is kind of what we do. So we don't just do regular print. It's not just a regular card. It's actually a card that uses electronic modules. So that's a sound module that we have. And when you open the card.
Hi there. I'm Kenya Hyman, the Director of Financial Aid at bigDAWGS College. I know this year has been a real challenge when it comes to the financial aid process. You've been waiting a while.
So it's actually an audio card. And these do really well when used properly. And that's it. I hope you enjoyed this video.